Hey everybody, so today we're going to be doing Kenobi, and looks like this walkthrough on exploiting a Linux machine, enumerating Samba for shares, manipulate a vulnerable version of Pro FTP D, and escalate your privileges with the path variable manipulation. All right, so first we'll deploy the machine, and it says here, make sure you're connected to the network, deploy the machine, scan the machine with Nmap, how many ports are open. So let's go ahead and conduct an Nmap scan on our remote host, copy to clipboard, ping, and I'll just drop my IP in there, bam. All right, cool. So nmap, and we'll run the script default, and I'm just gonna change the IP address to 231.124. All right, and it's gonna run a default nmap scan. We'll give that a second. And you can see I already know the answers. The answer is 7 right there. As always, I'm going to go ahead and put the answers in the description. Some cases where I can't fit it in the description, I'll put it in the comment section. All right, task 1. And we'll go look at task 2. Looks like it's still running the scan. Give that a sec. So while that scan is running, we'll go ahead and read over this. Samba. Samba is a standard Windows interoperability suite for programs for Linux and Unix. It allows end users to access the user files, printers, and other commonly shared resources on a company's intranet or internet. It's often referred to as a network file system. Samba is based on the Common Client Server Protocol of Server Message Block (SMB). SMB is developed only for Windows. Without Samba, other computer platforms would be isolated from Windows machines, even if they were part of the same network. So Samba is really just the SMB version for Linux. Using Nmap, we can enumerate a machine for SMB shares. Nmap has the ability to run to automate a wide variety of network tasks. There's a script to enumerate shares. So this is the script we'll use to enumerate the Samba shares. Samba has 2 ports, 445 and 139. And if we look at this image here, it says port 139. Samba originally ran on top of NetBIOS using port 139. NetBIOS is an older transport layer that allows Windows computers to talk to each other on the same network. And port 445, later versions of SMB after Windows 2000 began using port 445 on top of TCP stack. Using TCP allows SMB to work over the internet. So for the most part, you're going to be using port 445. NetBIOS is the older one. Almost distribution of Linux SMB client is already installed. Let's inspect one of the shares. So you can run this to check a anonymous share. Using your machine, connect to the network shares. Once you've connected, list files and the shares. Can you see it? All right, so we'll go ahead and do that. And it looks like the scan's complete. So we can see, based off the scan, that we have port 21, 22, 80, 111, 139, 45, 445, 2049 open. So altogether, that's 3 right there. 4, 5, 6, 7. So that's 7 ports open. So you go ahead and put that if you haven't already, and then go ahead and use the above command to enumerate the shares. And this would be a good time to go ahead and put this in your notes, because you never know when you'll run into this, either on a CTF or an exam environment. I could tell you from prior exams, like let's just say I've taken an exam where this was on there. So it's definitely something that you want to know. Right. Let's go ahead and run it. and that could take a second. So it looks like it's using the scripts smb enum shares. So Nmap has quite a few scripts you can run. You see, I run the default one. To begin with, I really like the default script because it shows me quite a bit of information here. It didn't show me the FTP version, but that could run a script that will show that later. And right off the bat, you can see that SMB is not very secure, as you're able to get in with the guest account. All right, let's take a look here. So here we're able to, again, see some of the same information, just guest and this share IPC cache anonymous, which is the one that we will take a look at next. Print money, and let's go and take a look at anonymous. So we'll go ahead and grab this. Oh, not that, just this. So we've seen 3 shares. You could go ahead and put 3 right there. Grab this, go over here, drop this in. And for the password, I don't believe we have a password. We'll just leave it blank. All right, and we're in. So for SMB, sometimes you don't need a password to authenticate, and it's always worth trying either guest or anonymous to see if you're able to actually get in. So let me go ahead and do an ls. And here we can see that we have a log.txt. So we'll go ahead and cat log.txt. And it looks like it doesn't want to do that for us. So we will get log.txt. And it looks like it's went ahead and downloaded the file onto our local computer. So we'll go and take a look here. So go ahead and put log.txt in for that answer there. And again, I'm going to keep track of the answers on my little notepad. Okay, you can recursively download the SMB shares too, submit the username and password as nothing. And here we're able to get in, open the file on the share. There's a few interesting things found. Information generated for Kenobi when generating an SSH key for the user. Information about Pro FTPD server. Right. So which port does FTP run on? Without even looking at the scan, if you studied for any exams, you would know that FTP runs on port 21. Okay. Your earlier Nmap scan will have shown port 1111 running the service RPC bind. This is just a server that converts remote procedure calls RPC program numbers into universal addresses. When an RPC service is started, it tells RPC bind to address it, at which it is listening, and the RPC program number it's prepared to serve. In our case, port 111 is used to access the file system. Let's use Nmap to enumerate this. So let's go ahead and enumerate that next. Before we do that, let's go ahead and take a look at the contents of this file here. So I'm going to go ahead and exit. We'll go ahead and cat log.txt. And after catting log.txt, you can see that it's provided us with some information here, whatever's in that file. And this file has quite a bit of content. Looks like it's got some information about an RSA key. And we can see where the RSA key is located. Fingerprint is you're right. So you can see port 21. So this has to do with FTP. It's got the output for when that key was created. And it looks like FTP might allow for anonymous access. And I'm just going to scroll through this. Okay, so this is some good information here. Trying to see if I can find any passwords. I don't see any. Although I'm just skimming it, so perhaps I'm missing something. Anyhow, we'll move on and we'll iterate the RPC port. Here we go. Copy that in there. Run the mmap scan. All right, you can see you have the var that you can mount to. So what mount can we see? Var. Perfect. All right, let's go ahead and move on to task 3. Let me go ahead and collect the information I need here. All right, task 3, FTPD. FTPD is a free open source FTP server compatible with Unix and Windows systems. It has been vulnerable in the past software versions. Let's get the version FTPD, use netcat to connect to the machine on the FTP port. What version is it? Okay, so we use nc cat put the IP address 3124, right, and over port 21. Okay, and you can see that it is FTP 1.3.5. So we can go ahead and input that for the version information. We can use search exploit to find exploits for a particular software version. Search exploit is basically just a command line search tool for exploit DB. How many exploits are there for FTPD running? All right, so let's go ahead and use search exploit to check that. So search exploit FTP. All right, so you can see there's quite a few here for FTPD within search exploit. I think what they're referring to is possibly just a version that we're looking for. So let me try to do that instead. There we go. So that cuts down on some of the exploits here. Now I have recently updated my search exploit. So we're actually seeing what looks to be like 4 exploits. Whereas what they're showing here actually is 4 exploits. Okay, maybe 5 copy file. Perhaps that's not seen as an exploit. So anyhow, just put 4 and you should be good to go. Let's look at the hint. Search exploit version. Yeah, okay. You should have found exploit for Pro FTPD mod copy module. I think that was the one I was just looking at. Mod copy module. Mod copy. There's actually quite a few of them here. There's this one for Metasploit, which can or cannot use. We'll take a look at that. This one's a Python script. I'd much rather use that one. All right. The mod copy module implements site cpfr and site cpto commands, which can be used to send file directories from one place to another on the server. Any unauthenticated client can leverage these commands to copy files from any part of the file system to a chosen destination. We know that the FTP service is running as Kenobi user from the file on the share, and an SSH key is generated for that user. So it sounds like to me we might be trying to get that SSH key. Okay, we're going to copy Kenobi's private key using site cpfr site cpto commands. Okay, cool. So it looks like once we try logging in, we'll use this command to then try to grab the key copy it over. All right, cool. So it provides us all the information we need. It's a very easy walkthrough. Go ahead and pull up a. There we go. Now I'm just going to go ahead and exit out of this because it might have timed out. So I'm just going to try this again. Right. And go ahead and put it there. Site cpto folder temp /id. All right, we copied it. Great. All right, so now that we've copied it, we'll go ahead and exit that out. Okay, we knew the var directory was the amount we can see in task 2, question 4. So we've now moved Kenobi's private key to the var temp directory. Okay, got it. Let's mount to the var temp directory to our machine. So we're going to create a mountable folder there. We're then going to mount from their machine to ours, and then we're going to list out the contents of whatever is in that share. Now we have our network mount on our deployed machine. We can go to the var temp and get the private key and then log in to Kenobi's account. Very easy. Okay, so let me go ahead and do this, but let's go ahead and try something here. So I am going to mount. So let me go to my mount directory here. So cd ls. All right, great. And we'll cd to. All right, great. And looks like I've done this one before, so you could actually see I have a folder for that. All right, I'm gonna go ahead and run this first command, and it should overwrite that folder. I don't think we have an issue with that. Okay, so I might have to delete that folder then. So C and dir. All right. All right, let me try this again. And I'll pause this portion. All right, looks like I removed it. So now we'll go ahead and run that first command again. Okay. So we need to do this sudo. Perfect. All right, so ls, we got it. Great. So next we're going to go ahead and mount to our victim. All right. All right, let me go ahead and sudo here. Should work. So mounting, it's kind of like when you plug a USB into your computer sees that as a storage location, essentially. And so if we're able to mount to another computer, it's kind of like when you're at work and you try to access a network share, in a sense that your computer is seeing that as like a area where you can store things, where you can connect to, and that's essentially what we're doing here. So let's go ahead and list out the contents of Kenobi, which has a private key. All right, great. So here we have the contents. Now we have a network mount on our deployed machines. We can go to var temp and get the private key. All right, so where's the var temp file? CP. All right, so we'll just run the file, the commands they have here, right? So we'll just run those commands there. All right, and we're copying that id.rsay into our directory. If this works, permission denied. Okay, so you may have to use sudo when you're running this, and that worked. Okay, perfect. And it's sudo chmod, and then we're making that key executable here. Okay, now we're going to SSH in that key. And we just download it to this specific location, so it's not going to be in any other location, right? It's going to be here. This is where that's why the dot's there. That dot is for this location, right? So that period dot. All right, so 239 239150. Okay, it looks like I'm missing a 10 in there. And let's see if this works. Could not resolve host name. Huh. Okay, interesting. Still have 36 minutes. That should have worked. Let me go ahead and, oh, no, that should work. All right, hold on. Let me do this again. So we'll leave out the Kenobi in there. Oh, it's the I. I forgot my dash I. That's why. Oh gosh, this is why I can't be a coder. I always forget like the little tags and semicolons and commas. Okay, we'll just give that a second. Hopefully it lets us in. I'm gonna look at the next task here. So next task. Privilege escalation with path variable manipulation. Looks like we're looking for the S for the sudos. Let's see, is this letting me in? Huh. Just taking a bit longer than usual. Well, we'll give that a second. I'll go ahead and pause this. All right, guys, so just to let you know, I accidentally put the IP address wrong. So when you're reading through this, it's not going to give you the IP address of your machine. You're going to have to change that IP address to the target machine that you have up here, okay? Now, sometimes I just get in the habit of just typing whatever I see, and you gotta think about it. So I'm gonna click yes here, and I'm in. Oh, actually, it's asking for the password. Okay, so for the password, we shouldn't have to provide a password. That's why we have the SSH key. Okay, so it's asking for the password. Okay, that was my fault. I gave the wrong permissions to the ID_RSA. So that needs to be sudo chmod 600. I think I did plus X for executable. So used to doing that. Actually, that will not work. So, hey, learning something in the process, making little mistakes, fixing them, moving on. All right, looks like there's a flag here we need to get. So let's go ahead and ls cat users user text here. All right, and boom, you got the flag. There's the flag, guys. So you copy that, come over here and paste it. All right, let's look at the next task here. And I only have 24 minutes left, so we'll make this one quick. Privilege escalation with path variables. So first we must understand what the SUID, SGID, and sticky bit are. So the SUID permission on files, users execute the file with permissions of the file owner. Okay, so if they're root, then they can execute that as root. And then SGID, users execute the file with the permissions of the group owner, so that G is for group. And here on directories, file creates in the directory gets the same group owner. So executes as the group owner. And then sticky bit, so on file no meaning, but on directories, users are prevented from deleting files from other users. Okay. And that's what it looks like. You got T, S there, and S here for SUID. SUID bits can be dangerous. Some binaries, such as password, need to be run with elevated privileges as it's resetting your password on the system. However, other custom files that have the SUID bit can lead to all sorts of issues. To search the system for these type of files, run the following. So this is a great one to have in your notes. Definitely going to run it on some type of exam or something like that sort. So we'll go ahead and run it. So run it within our SSH session, ran it, and we can find one for so find firm, and then we're looking for that specific SUID. Oops, it's taking type and send the errors to dev null. So let's see here. The file looks particularly out of the ordinary. So looking at the list here, it would be the menu file. So here we have the menu file here. You can actually take a look at these at GTO. Let me go ahead and pull up the site here. GTFO bins. So they have a site called GTFO bins. So if you have a SUID, you can compromise it. And if you're unsure whether or not any of these can be exploited, you can just type in, so this one's sudo, right? You can just copy that here and throw it in here in the search. And you can see there's no SUID bits that you can actually compromise from that. So, but if you put in menu, let's see if menu brings up anything. Menu doesn't bring up anything either. So let's see, let's look into this a little further because this is interesting. All right. Let's run the binary. How many options appear? All right, so I guess we could just run this binary, right? Let's run it. File or directory. Give me 1 sec. Okay, guys, so what I had to do, and let me just go ahead and scroll back up here, right here. So actually, we know that the binaries in user bin and in the binaries menu. So I had to cd into that location. So if you do cd ... it will go back directory, and then you go ahead and just go into that directory manually. So go into the temp user bin directory, so cd into the user and cd into the bin directory. Then if you try to cd into menu, you can't, because that's not a directory, that's a binary. So I did ls space dash la, and then that listed everything that's in that directory to include any binaries. So right away I can see that menu is in fact a binary, and so I will run the binary. So let me scroll down. So I do dot / menu, and that runs the binary, and you can see that there's 3 options there, and we have to enter a choice. So let me go back up here. So run the binary, how many options appear? So we know from running it that there's 3. So let me go ahead and input this for the answers here. So it's task 3. Grab this. All right. String is a command on Linux that looks for human readable strings in a binary. Right. This shows us the binary is running without a full path, not using /user bin, curl, or user bin uname. As this file runs its root user privileges, we can manipulate our path, gain a root shell. So let's go ahead and try this. Exit this here. All right, curl -i localhost. Okay. Rename. Looks like we're doing some enumeration here. R. Now it's looking for, that's for the kernel, and ifconfig is for the network configurations. Right. And then we can use echo bin /sh curl. Permission denied. Okay. Looks like we're in the temp directory, so we need to go to the temp directory. So let's go ahead and go back a directory here. cd temp. All right, so echo /bin sh curl chmod 7777 curl. Oh, I see. Okay. So the binary is running without the full path. So there's no, so that means that we can run this binary and from a different path with our own, we can manipulate it so that when it opens this binary put within the temp directory, that binary will essentially create a shell for us. That's why it's doing bin sh, right? Because we're trying to create a shell for ourselves here, right? So that's creating our shell. We're going to throw that in the curl, and then we're making curl. We're going to curl permissions, and then from there, when we run curl, it's going to look at the path and let's see here. So export path. So now we're adding that to the path. If I'm confusing you at all, we'll read through what it provides us. So, yep, so we're adding that to the path. Then we're doing user /bin /menu. right? And then from here, enter 1 for status check. ID, and we got root. So let's figure out what's going on here, right? So we copied the bin sh shell, called it curl, gave it the correct permissions, and then put in the location of our path, right? This means that when the user bin menu binary was run, it uses our path variable to find the curl binary, which is actually a version of user sh. So when it looks for, so we run the binary, and then the binary looks for the curl variable, and we specify that the curl variable is in fact in the temp directory here. Not just is it in the temp directory, but that curl is actually not curl. It's actually going to spawn a shell for us, right? Which is actually a version of the user sh, as well as the file being run as root runs our shell as root. Right? So it runs our shell as root. So now when it's looking for the curl, it sees it there, and then when it runs this file in this location, which we've specified here in the path, it's actually going to run as root, right? Primarily because the SUID doesn't let go of its permissions and it's owned by root. So I feel like we went a little too fast there and you may have missed that, but let me go ahead and go back to that so you can see. But for the meantime, what we'll do is we will just get the flag since we are here. So you do ls cd dash dash. All right, we'll go into the roots. ls cat root.txt. All right, and then we got the root flag there. And then there's quite a few things going on here, so if you're lost at all, it's okay because I was totally lost when I learned this type of stuff, and I still am kind of lost to be honest with you. I would run linps and then let linp show me where this SUID was, and then from there I would have looked at the logic behind the binary, and after finding a logic, then yeah, you can use something like this to find out that it's running the curl command there. And let's go ahead and look at that quick. So here's the location of the file. Let me pull up menu. I still have it listed here. So this is menu right here, I believe. Oh no, that's that menu. Let me go to my M's. I think this is menu. That looks like menu. Let me just verify. Yep, that's menu. So if that's menu, you can see it's got the SUID right there set. You see that little S right there? And this is run as root. So when you run the menu command or the binary there, it runs as root, which is dangerous because if we can get that binary to point, if point any variable towards another location, then it will run that variable as root. In this case, when it was looking for the curl command, and we said, hey, the curl command is here in the temp directory, and it thought it was running the curl command, but in fact, it was running a shell that gave us root access, right? Because it runs as root, because menu runs as root. So anyway, I hope I didn't confuse you guys too much. I hope you guys learned something in the process here. And if you haven't already, please think about subscribing to my channel because I am constantly posting content. And this box right here was on my list for the OSCP. So now what I'm gonna do is I'm gonna go ahead and mark this one off. And after this, I'm gonna turn to Hack the Box Academy, which I highly recommend if you haven't seen my video on it. I think Hack the Box Academy will teach you what you need to know about Active Directory, which is huge when it comes to OSCP, because if you can literally pass the Active Directory portion and do your write-up, you'll pass the exam. Like, you don't even have to do anything else, right? Like, knowing Active Directory is critical to passing the OSCP. You simply can't just do boxes, right? You have to know Active Directory at this point. So I'm doing Hack the Box Academy. They have some great courses on it. They even have some cheat sheets that you can use, and I'm loving it. Anyhow, I'm going to try to post as much content as I can within the next few days because I am very close to actually getting paid through YouTube finally. And the great part about that is I'm actually going to use that money to re-up my TRYHACKME subscription because, as you see here, I no longer have the paid version. So I'm going to use that money so I can actually create more content. So by you subscribing or watching my videos, you're definitely helping me do that. Anyhow, hope you guys enjoy this. Danny out.